So for this next example, we've got 4 parts to the question. So it says let z equal to cos theta plus I sine theta, and the A says show z to the power of n minus z to the power of negative n equals to 2I sine n theta. Sorry, n theta there. N theta. B says expand z minus z to the power of negative 1 to the power of 5. Expand that. C, use part A and B to show this, which is De Morgan's theorem. And then the last one is a bit challenging with the integral right there. So we'll start with A and see how we go. So A says show z to the power of n minus z to the power of negative n equals to that. So for this, we got to understand this part here first, which is that. So sorry, that is the conjugate of this. So if we know z to the power of n, the conjugate of that would then be z to the power of negative n. So an easier way to write this, which will help us understand and use this part here, would be z to the power of n minus z to the power of n, but we add like a little bar at the top, so like a line. It says z to the power of n bar. Now, which makes it real easy to solve this, we can just sub this into that. So we go there equals to, we've got cos theta plus I sine theta to the power of n, well then just from De Morgan's theorem we get cos n theta plus I sine n theta minus, put a little bracket there just to help us understand. The conjugate of this would just be, we just replace that with a minus, so we go cos n theta minus I sine n theta. Simplify that further, cos n theta, rewrite it, cos n theta plus I sine n theta minus, we got a minus here, cos n theta, and the minus minus then become a plus, plus I sine n theta, which then this and that cancel and that add together, which is 2I sine n theta, which equals to RHS. So that's how you do part A. Now we'll go on to part B. Let me write this out. So part B suggests, tells us to expand this. So we use, the best way to go about this is use binomial expansion from extension 1 maths. So let's just go ahead and do that. So I'll do this right here to make it a bit easier. B would be, oh actually no, I'll just do it at the top. Make it a bit smaller though. So Z minus, another way I could make this a little easier for myself is rewrite this as 1 upon Z, just to make things a little less complicated with the minuses. So 1 upon Z to the power of 5 equals to, we'll start with, obviously we've got 5C0 Z to the power of 5 minus, don't forget the minus, we've got 5C1, we've got Z to the power of 4, and then we've got 1 upon Z to the power of, sorry, we put a plus there, my bad. It's always a plus, and then this then becomes a negative because it's to the power of 1, plus 5C2, we have Z to the power of 3 minus 1 upon Z to the power, it's all squared, plus 5C3, my bad, 5C3, we've got Z squared, negative 1 upon Z to the power of 3, plus 5C4, Z multiplied by 1 upon Z to the power of 4, plus 5C5, negative 1 upon Z to the power of 5. Now we can simplify this over here. 5C0 is just 1 So we have z to the power of 5. Now, 5c1 is 5. Z to the power of 4. So the minus can just come at the front. So we have minus 5 and then z to the power of 4 upon z. The 1 and the 4 cancel out, which then becomes z cubed. 5z cubed. We keep the plus because the minus is there, but you square it the inside. So we have the plus 5c2, which is 10. We've got z cubed upon z squared, which is just z. And then again, we've got a minus here because minus comes in front. Because when you cube minus z, all cubed is still minus. Still get a minus there. So that comes in front. 5c3, I believe, is still 10. We've got to the power of negative 1. Yep, 10 to the power of negative 1. And then we've got 5c4 minus the power of 4 cancels, become positive, plus we've got 5c5, z to the power of negative 3, and then we've got another minus, z, 5c5 is just 1, z to the power of 5. So there is the expansion of this. So now it says for C, use part A and B. So use both of these to show that 16 sine to the power of 5 theta equals to sine 5 theta minus 5 sine 3 theta plus 10 sine theta. Okay. So the first step, I need this. I'll rub all this out. I need the bottom part because that's my answer. Sure, I'll write over here. Z to the power of 5 minus 5z squared plus 10z minus 10z to the power of negative 1 plus 5z to the power of negative 3 minus z to the power of negative 5. Okay, so I've gotten that down. First thing I will do to this is rearrange. Sorry, this is a 3. It's a 3. First thing I'll do, I'll rearrange all of these so that the powers are, the number of each power like equal to each other. So let's rearrange this and this. So we have z to the power of 5 minus z to the power of negative 5 per minus 10. We can have, sorry, minus 5. Because it needs to match this here. So minus 5. We've got z to the power of 3 minus, correct? Minus z to the power of negative 3. And then last one would be plus 10. Because we've got the plus 10 here, we go z minus z to the negative 1. There, so now I've rearranged this. So this equals to that. But if we come back to this over here, z to the n minus z to the negative n. So z to the 1 minus z to the negative 1 to the power of 5 equals to this. So I can sub this down here. So let's rewrite that. So we have 2i sine, but n in this case is just 1, theta to the power of 5 equals to this. Or is it? Yeah, equal to that. Which would be equal to because to the power of 5, right? So that would be n. So that would be 2i sine 5 theta. That's right, 2i sine 5 theta minus 5. Or in this case, 10. In this case would be 10 minus 10 I sine 3 theta plus 20 I sine theta. That's what this equals to that. So we've just basically just subbed out these this with that, but adding the ends. So the next step would be have that to the power of 5. So this is, I'm using C. This is for part C. So for the next part would be just equate this. So 2 to the power of 5 would be 32. I to the power of 5 is just I sine 5 to the power of 5 theta, which would then equal to the same thing, which would be 2I sine 5 theta minus 10I sine 3 theta plus 20, sorry my bad, I sine theta, right? What is common here that we can all take out? 2I, in this case, is common between both ways, so divide both sides by 2I, which then we divide both sides by 2I. Make a little, oh, it doesn't really matter. Divide both sides by 2I. This then becomes 16 sine to the power of 5 theta, which equals to 2I cancel sine 5 theta minus 5 sine 3 theta plus 10 sine theta, which is then equal to the same thing. So 16 sine to the power of 5 theta, 16 sine to the power of 5 theta equals to sine 5 theta minus 5 sine 3 theta plus 10 sine theta. So now we'll look at D, which is it's a definite integral. So we're going to have a final value for this integral. We want to have a constant at the end. So let's get into it. So we've got sine to the power of 5 theta. Obviously that's really ugly if we go about just trying to solve it that way. But luckily we did the proof at the top to show that's 16 sine to the power of 5 equals to that. So the first thing I will do here, so I'll multiply both sides by 1 upon 16, which then cancels out this. That's how, in integration, that's what we do. If we've got a constant, we just multiply by 1 upon 16. So, once we divide both sides by 1 upon 16, this cancels out, and that then leaves us with this, sine to the power of 5 theta. So let's just go 1 upon 16. Same, definite integral, the limits are still the same, pi on 2. And we've got pi on 4. Now for this, we just replace it with that. So we have sine 5 theta minus 5 sine 3 theta plus 10 sine theta. D theta, don't forget that. Now, since we've got 3 separate parts, we can just integrate them one by one, just like when we differentiate. So this then becomes real easy. We've got 1 upon 16, big brackets. When we integrate sine 5 theta, we're going to get negative cos. When we integrate sine, we get negative cos. So this then becomes minus cos 5 theta upon 5, because we've got to make sure we bring the, so sine n theta, when we integrate that, it's 1 upon n cos n theta. So, sorry, negative 1 upon n cos n theta. So same thing, so we're going to have that there. But since we've got a minus in front of the sine, this then becomes positive, the cos. So same thing, 5 cos 3 theta all upon 3, because the n and the 3. And then the top again, minus, we've got 10 sine theta would be just 10 cos theta. 10 cos n in this case is just 1. So 10 cos theta. And make sure we've got the 2 limits. So pi on 2 is a larger number, so it goes on top. Pi on 4 is smaller, so upon 4. Next step, we add, so we sub in pi on 2 to all of this, but since cos pi on 2 is always 0, cos 90 is 0, because like if we draw up the graph of cos theta, we've got something like this. That's what cos theta is. 0, pi on 2, pi, 3 pi on 2, 2 pi. So cos 90, it gives me 0. So for pi on 2, the values don't mean anything, basically. So this then becomes equals to 0 minus 1 upon 16. Now we've got the minus because we minus that upon that. So A, we got A and then we minus for the B. In this case, pi on 4. So that then becomes, boom, outside, cos 5 pi on 4 upon 5. We have cos 5 pi on 4 upon 5 plus, don't forget the minus, we'll worry about this after, just leave the bracket inside first. So that minus this, so we've got 3 pi on 4, so we've got 5 cos 3 pi on 4 all upon 3 minus 10 cos pi on 4. We can equate the inside now. We'll worry about the minuses after this. So 5 pi on 4 gives me, put my calculator in radians mode, make it easier. So cos 5 pi upon 4 gives me negative 1 on root 2. Negative, negative cancel becomes positive. So 1 upon 5 root 2 plus 3 pi on 4. Again, negative 1 on root 2. So 5 upon, sorry, this would then become minus 5 upon 3 root 2. Yep. Minus cos should give me 1 on root 2. So 10 on root 2. But we still haven't multiplied by the negative 16. So now we change so this is also negative. Or is it? No, it's not. Because we got the yeah, my bad. That becomes positive. So now same thing, we have minus 1 upon 16 times 5. 80 root 2. Root 2 plus 16 is 48. 5 on 48 root 2 minus, sorry, plus, we got the thing right here, plus 10 on 16 root 2. We can further simplify that, which will then become, I'll rearrange this, so we've got 10 on 16, so if 2 5s are 2, 8 are 16, so 5 on 8 root 2, 5 on 48 root 2, minus 1 on 80 root 2. Further simplify that, multiply both sides by root 2. 5 root 2 plus 5 root 2 minus root 2. 5, that becomes 16. 48 times 2 is, what's 48 times 2? Gives me 48 multiplied by 2 is 96. 96 upon 80 times 2 is 160. 160. So, lowest common denominator. Multiply this by 96, 160. Multiply this by 16, 160. Multiply this by 16 and 96. So 16 times 96 times 160 is 254. We'll just leave it at this for now, because it might get a little messy. But yeah, that should be the final answer for this integral right here.